In this video, we are going to look at the definition of derivative. This is a concept heavily used in calculus, so it's really important. We highlighted it in red here. You can see that the derivative is defined as f prime of x. That notation means we're taking the derivative, and it's the limit as h approaches 0 of f of x plus some value h minus f of x over h, if the limit exists. Now, f prime of x exists for each x in the open interval a to b, then f is said to be differentiable over ab. Now, the derivative that we have here, f prime of x, is equal to the slope of the tangent line at some point. It's also called the instantaneous rate of change, and it's also called the velocity. So let's try it for example 4 here. In example 4, they want us to find the derivative for the function f of x equals 8x minus 2x squared. So let's write the definition of derivative down here. From above, our definition of derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. Let's first explore this part of our numerator here, this f of x plus h. F of x plus h is what we get when we substitute x plus h in for x. So if I wrote this equation, 8x squared minus 2x, oops, it's not squared, 8x minus 2x squared. Okay, so I just put parentheses where that x is supposed to be, right? But instead of just having an x in there, we're going to substitute in an x plus h. So it really looks like this. We substitute that x plus h in where there was an x. Then we clean this up. So 8 times x plus h is 8x plus 8h using the distributive property. And back here, the 2 times x plus h squared. Remember, x plus h squared is really foiling, which gives us x squared plus 2xh plus h squared. So we're going to put that in here. Squared, like that. And we multiply it out. 2x squared plus 4xh plus 2h squared. So this whole thing is the same as this part of our numerator. Rewriting this, we're going to get this. So here we have that limit as h approaches 0 of 8x plus 8h minus 2x squared plus 4xh plus 2h squared, which is just really this part. Now, subtracting f of x is just our original function. F of x is 8x minus 2x squared. So this part of our numerator is just that there. And that's all over h. Now we try to clean it up. Let's write this again. So when we write it again, this negative in front that's subtracting f of x here is going to change the sign of those terms. So that'll become a negative 8x and a positive 2x squared. If we've done this correctly, everything highlighted in blue here is going to cancel with something in the previous part. So I have a negative 8x squared, or a negative 8x, which cancels with a positive 8x, and a plus 2x squared, which cancels with the negative 2x squared. What we're left with are the remaining terms. Let's write those. There's 3 terms in our numerator, and we notice that each of them has got an h in it. So we're going to factor that out as we've done before. And we'll have the limit as h approaches 0 of h times 8 plus 4x plus 2h over h. Now, the rule for canceling in fractions is that anything being multiplied can cancel. So this h, which is being multiplied by everything, can cancel with 1 in the denominator. This one cannot because it's not being multiplied by everything. This leaves us with the limit as h approaches 0 of 8 plus 4x plus 2h. But now is after we've gotten rid of our h in our denominator is when we take care of this part of our problem, which says the limit as h approaches 0. So in this case, this term is going to approach 0 because 2 times 0 is 0. So our final answer is 8 plus 4x. And that's how we use the definition of derivative to find the derivative of a function, especially a quadratic. Here are those steps in more detail. You can see here, it says find f of x plus h, which is what we did up here. We found f of x plus h first. Then it says subtract the 2, which we have in our numerator. Here's f of x plus h, and here's f of x. And then find f of x. I kind of put it all in the same problem, but it says to subtract those, that's where we got 8h plus 4xh plus 2h squared over h. And then we find the limit as it approaches 0. That is the process. In our next video, we will practice a few more.